Right, hey guys, welcome back to another video. So something that I want to start off as well is, for those of you watching, I just want to go over the quadratic formula and when that might come in useful. So what the quadratic formula does is it allows you to solve for the roots of an equation, right? So let's say you're given an equation like x squared minus x minus 30. And yeah, let's say y equals all of this, right? Our issue is that we need to find, um, let's say potentially when the x-intercepts of this graph, right? So what we will do is to solve something like this, we'll either have to factorize it or potentially graph it and look for the intercepts. But all of these things are kind of difficult. One thing that we can do to make finding the x-intercepts easy is we can just use the standardized formula, which is the quadratic formula, right? And yep, so in a standardized case, what I'll do is I'll write out the formula for you. So if you have ax squared, and a is just the coefficient of x squared, plus bx plus c, where a, b, and c are all constants. And let's say we're solving for the x-intercept, so when that's equal to 0, or yeah. Now how the formula goes is, it just goes x equals minus b, so the minus of this coefficient plus minus square root b squared minus 4 times a times c. So 4 times a times c. Note I used dots, I'm just used to it, but it just means times. All divided by 2a. Okay, so make sure you write that down somewhere, you keep it in mind. For those of you studying in New South Wales, they'll be on your formula or data sheet, and you can always just refer to this. It's just a quadratic formula. So now let's actually learn how we can apply this in a practical sense, right? So let's take all this away. If you don't want to factorize it, or if you think something's too tough to factorize, we can just plug it straight into the formula. So x equals, what we know about this is if we don't see anything before the x, we know the coefficient is just 1, right? It's the same thing as if you have like c, if you have z, right? Z on its own is just 1z, pretty much, so it makes no difference. And that's how it works. Now, the coefficient of this x you might think is just 1 as well, which you are correct in that sense, it is 1. But what you have to make sure is you take account of the symbol before it. So this coefficient will actually be negative 1 instead of just 1. Same as this 30. We have to take account of this, the symbol before it. So it's not just 30, it'll be minus 30. So that we know is our A, B, and C now. Now plugging it in the quadratic formula, it's minus b, so minus bracket minus 1, plus minus the square root of b squared, minus 1 squared, plus 4 times 1 times c, which is minus 30. Yeah. All divided by 2a, which is 2 times 1. So yeah, minus b plus minus the root of b squared plus b squared minus 4ac, b squared minus 4ac, all divided by 2a. So yeah, make sure you have a minus here. Now let's proceed with this. What do we get out of it? So minus times minus, we get positive, so it's just positive 1 plus minus the square root of minus 1 squared. Remember, when the minus is inside the brackets too, it's just minus 1 times minus 1, which gives us positive 1. What I like to think about this is because I see that there's a minus here and also a minus, and we're multiplying them, we take it as plus. So plus 4 times 1 times 30 gives us 120, all divided by 2, right? So yeah, so we get equals the square root of 121 gives us is just 11. But before we get there, so it's 1 plus minus root 121 all on 2. Okay, cool. I'm just going to clear this so I get more space. All right, fabulous. So 1 plus minus, remember we said the root of 121 is just equal to 11, all divided by 2, which means it'll be 1 plus 11 on 2. That's our first solution, taking just the positive of the plus minus. Our second solution is given by 1 minus 11 on 2, which what we can see is it's 12 on 2, and it's also minus 10 on 2. If we simplify these numbers, it will just be equal to 6, and it'll be equal to minus 5, right? So those are our solutions. Now, to make sure that our formula works in this case, right, what we have to do is we can also factorize it and see if we get the same thing, right? So what I'll do is I'll leave our answer there, and I'll just factorize this. Earlier, if you see my video on the cross method, you can apply this same thing, and I'll go through the same principle. So x and x, what two numbers multiply together gives us minus 30, but also after multiplying them diagonally and adding them, it gives us minus 1. So what I'm thinking is it'll be potentially 5 and 6. Now, the order of it matters. Because we know that it will give us a minus 30, one of them has to be a negative, so they're going to be alternating in sign. And it's going to add to a minus 1x, which means the negative has to be on the larger number. So minus 6 plus 5. Let's try that. So 5 times minus 6, minus 30. X times x is just 1x squared. And now going across the diagonals, so x and plus 5, we get plus 5x. Now x times minus 6, we get minus 6x, which is minus x, or minus 1x. So that's perfect. And writing this out, we get x minus 6, and then x plus 5. And yep, so that's the factorized version. If we let this equal 0 to find the x-intercepts, we know that x minus 6 equals 0, x plus 5 equals 0. So x equals minus 5 and x equals 6. And as we can see, 6 and 6 match, minus 5 and minus 5 match. So there we go. And that would be our solution to the quadratic formula. So yeah, just as a quick recap once again, you can use a quadratic formula for cases when you think factorizing might be too hard, or you can't factorize it using a cross method. You can just plug everything in the formula and it'll give you a number. And a note that I want to make about this is that it's not going to give you perfect numbers in every case. Sometimes you might get numbers like x equals, minus 7 plus minus the square root of, 132 on 6. And with a square root number of 132, we know it's not going to be perfect. It's going to be messy, it's going to be a crazy decimal. I can plug it in my calculator right now and I'll get 11.48912529. So sometimes it's easiest to just leave your answer like that. And that would be a valid answer. It's just minus 7 plus root 132 on 6, comma, minus 7 minus root 132 on 6. And those would be your two answers. So, yep, thanks for tuning in once again. This is the quadratic formula, the introduction to it, and I'll hope to see you guys in the next one. Take care.